Welcome to Train Signal. You're watching a video about wireless networks. In this video, I'm going to start off by posing a question to you, and that question is wireless good or bad? And then we'll talk about that answer. Then we'll go over some of the current wireless networking standards, some of the specifications that go with them, so we can decide what's the best wireless network for us. Then I'll talk to you about how to secure information on a wireless network. And then we'll wrap things up by actually going into Windows and showing you how to connect to a wireless network. So, here's the question for you. Do you think that wireless networks are a good thing, or do you think they are a bad thing? Really, what do you think? Go ahead, yell it out, good or bad? Well, I'll tell you what. I personally think the answer is a simple one. You may have found it simple as well. My simple answer is yes. Plain and simple. Wireless networks are definitely a good thing, and they're definitely a bad thing. So what is it that's good, and what is it that's bad about a wireless network? Well, wireless networks are good because they help eliminate the physical constraints which we previously have always had to deal with our wired networks. Matter of fact, there's two specific circumstances that I can think about that I was in where wired network was very, very difficult to darn near impossible. The first one is I was working as a network administrator for a company which resided in an old brick building in which we did not have any privileges to alter the structure of that building in any way at all. This made it very, very difficult to get cables from one location in the building to another location in the building. As a matter of fact, what we ended up having to do was add all kinds of extra exterior channeling throughout the office. So basically everywhere you went, you saw some kind of tube, and you didn't know what was in that tube, but you could see the tubes as opposed to having them hidden behind the walls. Now the other circumstance that I can tell you I've had to deal with is something that you very well likely can relate with. I know many people out there who relate with this, and that is at my house. Well, at my house, I have 6 computers, and I want them all networked. I want them talking to each other. And I didn't build this house. It's already built, already has walls, and I don't know about you, but I don't particularly like busting holes in the walls and running cables through them and dealing with things like insulation and existing piping and then having to patch and then, oops, I made a mistake, that's the wrong place, etc., etc. Now, if you find that fun, have at it. But in my case, that's not my cup of tea. So what I decided to do was go ahead and implement a wireless network, and boom, all 6 computers talk to each other. Didn't have to make a mark on a single wall. Now, wireless networks are bad because they create an additional security risk because they send data through the air. I mean, that's kind of the obvious one. Matter of fact, that's what kept wireless off the map for a long time. Pretty much in any scenario, if an intruder has physical access to data, if they work hard enough, they can find a way to hack into that. When you have a wired network, this is still true. If somebody has physical access to the infrastructure of your network, they can hack into it. But the difference is when you have physical cables connecting your network together, you can control exactly where those physical cables are and make sure that it's secure. When you are dealing with data traveling through the airways, you can only somewhat control where it goes. I mean, there are ways to give directional signals and control how strong the signal is and things like that to try to keep the signal where you want it to be. But there are many factors which include whether it be a change in the physical infrastructure of a building or climate changes in the weather. I mean, there's all kinds of things that can come into play which can push wireless signals somewhere that you don't want them to be. So what this means is no matter how hard you try, your wireless signal may travel outside of your secure environment And if somebody's out there waiting for it, they may now have access to data and therefore can begin hacking. Now we'll look at some of the ways that we can secure, or at least help secure, our wireless networks in just a little bit. But first, let's talk about some wireless networking standards. The first one I want to talk about is 802.11a. Now, I don't know if you've ever heard of 802.11a because many people have not. This is something that was around for a very short period of time and was really only in corporate environments. And one of the reasons it was only in a corporate environment is right here. It was very expensive. Now, the upside is we did get 54 megabits per second, which is quite fast. I mean, when it was first released, pretty much the fastest Ethernet when you're using a wired network was 100 megabits. So this was, half of that, which is pretty good. But it functioned up around 5 gigahertz, and so therefore it had a very short range. Another big downside. And as a matter of fact, 802.11a is something that, well, we might as well just almost say it never even existed because it's just gone. So let's just wipe that off of there and move on to something that is out there, which is 802.11b. 802.11b, some people actually think that this came out before A, because many people, just the common user who wanted to set up wireless at home, went out, bought a wireless router, and it was 802.11b. And it was later on that they heard of something called 802.11a. But the reality is, B came out after A, very shortly thereafter, and it works at the 2.4 gigahertz frequency, which gives it a much better range. Not only does it give it a better range, but it also travels through walls and other obstacles quite well. Now the downside is right here, 11 megabits per second, which is kind of slow. I mean, it's been a long time since we were dealing with 10 megabit Ethernet, and if you've ever dealt with it, you know exactly what I'm talking about. It is painful trying to work on a 10 megabit Ethernet network. But I'll tell you what, if you're using wireless, let's say at home, or even in a small office environment, and the main purpose is to share access to the internet, well, today's high-speed internet options are still usually slower than 11 megabits per second. So it's perfectly acceptable to use if you're using it on a small or home network for internet access. Now, 802.11b, although it is perfectly acceptable, it's kind of a thing of the past. So we'll kind of fade that out a little bit, and we'll talk about something that took its place, which is 802.11g. Now, 802.11g also, just like 802.11b, works 2.4 gigahertz frequency, but it created a much faster, we went back to the old 54 megabits speed, which is fast, very realistic to use, even within an internal network. The other cool thing about G is that it's completely backward compatible to 802.11b. There's the occasional 802.11g device that I've seen that is exclusive to G. But almost every single device I've ever seen is backward compatible to B. You'll see that all the time, where it's a B/G device. So G quickly, once it became cost effective, once the devices were able to be purchased for about the same price as 802.11b, that's what made B kind of a thing of the past. Now, even though 802.11g is still a very active wireless networking standard, there is another newer one out there, and that's 802.11n. And 802.11n, check this out, over 100 megabits per second is its capability. There's a lot of debate as to exactly what is the fastest speed you can get out of 802.11n. I've seen people talk about 160 megabits. I've even seen as much as 250 megabits. But it's very fast, and the way that we get that speed out of 802.11n is through a technology called MIMO. M-I-M-O, which stands for multiple in, multiple out. And it's just what it sounds like. We're basically using multiple channels. So even though we may have a limitation of 54 megabits per second on a single channel, well, by using multiple channels, we now have the ability to go ahead and increase that speed. Now, one thing that I'm going to caution you on with 802.11n, and that is that the standard is still not quite yet. They're really close, but not quite yet finalized. So the thing you need to be careful of is that it is possible to purchase one 802.11n device and it won't be compatible with another 802.11n device. But with that being said, I'll tell you that as of right now, almost all the 802.11n devices that I've seen out there are all compatible with one another. All the manufacturers, I mean, they're not stupid. Even though they may not have agreed 100% on this absolute standard, they're all working together to make sure that their stuff works because they know it's going to make them all successful. I personally have multiple wireless N networks, or I should say wireless N devices that do work with one another. The other nice thing about 802.11n is, again, most of the devices, not all, but most of the devices out there are backward compatible to B and G. So that way, if you wanted to get, let's say, your new 802.11n router, but yet you still have some old B and G wireless cards out there, maybe an old laptop that, as I give you for instance, my father-in-law has a laptop that he comes to my house with, and it supports 802.11b. And that's the card that's actually built into the laptop. He doesn't want to have to buy a new laptop just to connect to my network. So I needed to make sure that my 802.11n router was backward compatible to B, and it is. So those are the 4 wireless networking standards: A, B, G, and N. But primarily, G and N are the 2 that you're going to see heavily out there today. Now let's talk about wireless security. You'll notice that I put this word maybe next to wireless security. And again, that's because no matter what you do, if you are not able to prevent an intruder from grabbing signal out of the airways, well, then you're only maybe secure because you only maybe will stop that intruder from hacking into the information. So, what are some of the options that we have available to us? Well, the first one is to disable SSID broadcast. Now, SSID stands for Service Set Identifier. Okay, great. That's what it stands for, but what the heck is it? Well, it identifies your wireless network. If you have a wireless access point or a wireless router that you are using to allow wireless devices to connect into your network, well, the way they locate that device is through its SSID. Well, one of the things you can do is you can disable the SSID broadcast. See, by default, that wireless router, as a for instance, is going to go ahead and just kind of be broadcasting out, hey, I'm a wireless access point, and you can connect to me because my name is. If you disable that, now intruders won't necessarily know that you are there just by passing by your network. And this is something that is a very minimal level of security. Basically, this is going to keep somebody from accidentally finding your network and then deciding to hack into it. Maybe you have guests who come into your office, they bring laptops, they turn on the laptop, their wireless card says, hey, there's the network. Well, disabling the broadcast will prevent that from happening. Now, the next thing you can do is something called MAC filtering. And it is just what it sounds like. Every network card has a MAC address, a physical hardware address. On your wireless access point, you can filter what MAC addresses you are willing to allow into your network. So what that means is maybe you have your 5 users on your network who have laptops and they need to be able to connect. And that's all you need. All right, well, you can set up a filter that says, all right, well, let's just allow the 5 MAC addresses of those 5 wireless cards to connect. Anybody else, they're out. The problem there is that something called MAC spoofing is very easy to do. It does not take much effort at all to take a network card, a wireless network card, and give it a MAC address that is the same as one of the 5 on the list. So again, this is what we would probably say is a minimal level of security. Now, if we want to move up just a little bit, we could go to something called WEP. Okay, now actually, if you were to not look at the words and just look at WEP and think to yourself, what does that stand for? Well, it doesn't do a whole lot of good to ask you that because it's right here, wired equivalent protection. Well, the funny thing is the average person, when I ask them that question, they'll say it's the wireless encryption protocol. No, it stands for wired equivalent protection. And that was the idea. The idea when they developed WEP was to make your wireless network as secure as if it was wired. Well, guess what? Not even close. WEP, although it is more secure than something as simple as disabling your SSID broadcasts or filtering MAC addresses, it is a form of encryption that is very easy to break. WEP is something that you can put, matter of fact, it's very common that people will put WEP on a home network. And what that basically does is if somebody wants to connect to the network, they may see your SSID, you may not be filtering MACs, but they may go to connect, and then what's going to happen is there's going to be what's called a WEP key, an encryption key that they have to know to get in. Well, hacking that key is pretty much a no-brainer at this point. You can go on the internet, you can Google search to find WEP cracking keys, and there's all kinds of free ones out there, and you basically just find the wireless network, run the cracking tool, and you're in. It doesn't take that long to crack the code. So that's one thing to keep in mind with WEP. To move up from there, we can move to WPA, which stands for Wi-Fi Protected Access. This is a dramatic improvement over WEP. WPA, again, is a form of encryption where you need to have a key to go ahead and be able to communicate with the wireless network. But they've taken it to a much higher level, a much more advanced level of encryption, and the keys actually rotate. So even if somebody were to crack the key, depending on how long it takes them to do it, you may now be onto a new key, which does help keep attackers out. Now the last one on the list here is actually WPA2, which is really nothing more than a newer version of WPA. Okay, they're continually making advancements, and I don't think you'll ever see that stop. I don't think you'll ever see these advancements stop, because every time we come up with a way to secure a network, you have attackers out there who figure out a way to crack a network. So these are some of the things that you can do, and we'll take a look at, I'm going to actually show you a Linksys wireless router that I have here in the office with me, and I'm going to show you how you would set up each of these things. But remember, your wireless network can still only be so secure if the signal is traveling outside of secure boundaries. So now let's go actually take a look at how some of this works. I'll show you how to not only connect to a wireless network, but like I just said a moment ago, I will also show you how to set up some of the security on a wireless access point or router. Now, in order for me to demonstrate how to connect to a wireless network, I need to have a computer with a wireless network adapter, and none of our Global Mantix computers have wireless adapters. But I do have another computer on a network by me here that does have a wireless adapter, so I'm going to connect to that one. So I'm going to manually go ahead and do a remote desktop connection to that computer now. Now, don't worry about where I'm connecting. You can follow along by using any computer that has a wireless network adapter attached to it. Now, this particular computer is running Windows XP Professional, but it really doesn't matter what operating system you're running. The only thing that would really change is slight interface changes. As of, for instance, down here, there is an icon for the wireless network adapter. I'm going to right click and select View Available Wireless Networks. In Vista, you would right click on it and the menu item you would see would be Connect to a Network. It's the same thing. Now there's a few different networks here for me to choose from, and the one I'm going to go to is the wireless router I have in my office, which I've named Ed's Office. And you'll notice right now it says it's an unsecured wireless network. So I'm going to go ahead and click on it and then click Connect. Now it's giving me a little warning saying, hey, you realize that this is completely unsecure and anybody who's possibly looking on this wireless network would see everything that's traveling through the airways. And I'm going to say, yeah, for right now, connect anyway. And you'll notice that basically there's nothing else that I have to do. It's connected. It was acquiring an IP address as a DHCP client, and this particular router I have set up as a DHCP server, so now it is connected. I now have my connection to that wireless network. I don't know if you can get much simpler than that. Now that's how you would do it kind of in an automatic fashion. If you wanted to get a little more detailed with it, let me go ahead and right click on the icon and open my network connections window and then go to the properties of my wireless network connection. In these properties, I'm going to click on wireless networks. You'll see first of all that I now have a preferred network to Ed's Office, because once you connect to it once, it by default makes it preferred. I could eliminate that by removing it, or I could make changes to it by going to its properties, which we'll look at in just a little bit. But this checkbox right here, use Windows to configure my wireless network settings, it's a great thing. It pretty much allows Windows to automatically detect what type of signal, and when I say what type of signal, I don't mean B or G or anything like that, but as far as security signal, whether it's unsecured or whether it's using WEP or WPA, let it determine that and then guide you through it. So that's kind of cool. One other thing I want to point out to you before we leave this window is this advanced button. And this is where you can choose whether you are willing to connect this computer to another computer in what's called an ad hoc network. An ad hoc wireless network is a peer-to-peer, like literally laptop to laptop or wireless network card directly to another wireless network card, and is typically not used. It's very rare you would set that up, and it can be quite finicky. What is used is where you are in what's called infrastructure mode. That's right here, infrastructure, where you are only allowing access to connect to access points. Now I know I said I have a wireless router, but that wireless router is acting also as an access point. The default setting is either, but it will go to an access point first, and that's perfectly acceptable. But you should know those terms, ad hoc and infrastructure. Alright, so let's close that window. Before I close this, there is one other thing I want to show you, and that is if I wanted to manually configure this network, I can go to its properties and I can set everything up. Okay, I could say connect even if this network is not broadcasting, now that I know the name. I can choose whether we're going to have some form of data encryption. Okay, so we have different options available to us to go ahead and set up manually. Alright, so let's cancel out of here, and even close this window. Because the next thing I want to do, let me go ahead and minimize my computer here, is I want to show you how to set up security on the router. And so what I'm going to do is, believe it or not, most of today's wireless access points and routers are managed through Internet Explorer. So I'm open up Internet Explorer here, and it doesn't have to be Internet Explorer, it could be really any web browser. And right up here, I'm just going to put in the IP address of my Linksys router, which is 192.168.10.200. And what it's going to do is it's going to prompt me for a username and password. Now this is an Internet Explorer thing. The reality is Linksys routers only require a password. Let me type this in real quick. Some routers, like as for instance at home, I have a couple of routers, but one of them is a D-Link router, and it does indeed require both a username and a password. So you need to know that about the router you're working with. Click OK. And you'll see here that it takes me to the initial configuration page where it's showing me what kind of router it is, shows me what my IP address is. Here's the DHCP server aspect of things, just some basic stuff about the router. But what I want to show you is right here where we're going to go to wireless. Here's where you can see that the name of the SSID is Ed's Office. But down here, you'll see we have wireless SSID broadcast. If I disable that, SSID broadcast, then I would still be able to connect from a wireless device if I manually typed in the name Ed's Office, but I wouldn't see it when I went to view available wireless networks. So that's how you can disable SSID broadcast. I'm going to leave that enabled for right now. The next thing I want to show you is right here, wireless MAC filter. We can enable MAC filtering. We can choose one of two types of MAC filtering. We can create a list by editing the MAC filter list and then entering in the different MACs for the different network cards. But I can choose whether I want to prevent those MACs or permit those MACs. Okay, and so this is two different ways to go about it. One way is we can make a list and make it an exclusive only list. You're only getting in if you're on the list. Or I can say, no, I'm going to let pretty much anybody in, but if I know there's a problem child out there, I'll prevent that one. This is a great way if you happen to know that you have somebody who just keeps conveniently coming in your network and you see them on the list as making a connection. You say, I don't know who this is. I don't want them in my network. You can just go ahead and prevent that one without having to create a whole list of every MAC address. So those are our two minimal security settings where we can disable SSID broadcast and set up MAC filtering. Now I'm going to actually disable that as well because I'm not going to make changes to this particular router right now. But the last thing I want to show you is wireless security. You'll notice right now it's disabled. I could choose, instead of disabled, I could choose WEP if I wanted to set up WEP, which is a medium level security. The one reason why you might still use WEP is based upon what operating system your users are connecting with, that may be all they support. I don't know if you noticed, but because that other computer running Windows XP, I believe it is an older version. It's not service packed or anything. I'd have to go take a look. But I think it was only supporting WEP because the original versions of Windows XP didn't support WPA. Or we could go to WPA or WPA2. Now you'll notice that there's WPA Personal and there's WPA Enterprise. Basically, WPA Personal is exactly what it sounds like. It's for the smaller home type network, whereas WPA Enterprise is for the corporate environment. But here's the thing, when you're using Enterprise, you're also pretty much implementing Radius. Radius, which we talked about a little bit in the last video, which is where we have some form of centralized control. And actually with Radius, we can also implement something called certificate services to add an additional layer of security to our wireless network through something called 802.1x. That would be probably the highest level of security that you could possibly put into place. But WPA2 Enterprise can also be done without having to go full-blown Radius. Now, if I were to select WEP, then you'll notice here that I have to go ahead and put in a passphrase and or a key. Well, you don't put in the key, you generate the key. So if I put in a passphrase of, let's put P@SSW0RD, right? That's kind of like a complicated way of writing the word password. Generate. You'll see here it's generating some keys. And up here, you'll notice we're using either 64-bit encryption, which is 10 hex digits, or I could go to full-blown 128 and then generate a 26 hexadecimal key. Now, the only way that a client's going to get in is if they have this key. By default, it's going to use this key, unless it can't, because you'll notice the default transmit key is 1. Let's not worry too much about that. Now let's go ahead and see if, well, before we do, let's go ahead and save the settings. Now when we save these settings, what should happen, let me click continue, is I should now be disconnected on that wireless network card over on Computer D. Let's see if that is the case. Computer D, aha, you'll notice it is no longer connected. So if I right click and say view wireless networks, you'll see that Ed's office is there, but now it's a security enabled wireless network. So now if I highlight it and click connect, it wants a key. So what I would need to do, let me go ahead and minimize this here, is I would need to know this key right here. So that could be quite difficult, as you could imagine. If I go back to Computer D, paste that in. Now in this case I can do it because I'm going back and forth with the remote desktop. Let me click connect. And it looks like it's making the connection. It's looking for an IP address, and we are connected. All right. So as you can see, WEP did do the job of securing the network and also went ahead and worked when we had the key. But like I said, let me minimize this. Keeping track of a long key like that can be quite difficult. And if an attacker wanted to get in, there are all sorts of tools out there on the internet that can crack this key in a fairly quick time frame. All right, so that's pretty much how you set up a wireless network. The cool thing is that with today's operating systems and today's standards and today's wireless equipment, like today's wireless routers, etc., this stuff is all pretty intuitive and pretty easy to do. All right, so let's see what we've talked about in this video. In this video, we covered the 802.11 wireless networking standards. Remember, we have 802.11a, b, g, and n. We saw the advantages and disadvantages to each, so now you should be able to make a good decision as to which one you want to use. We looked at some different ways to secure a wireless network, but again, keeping in mind that the network can only be so secure as long as signal is traveling through the airwaves. And we also know how to connect to a wireless network. All right, well, that pretty much ends the wonderful world of wireless networks. I'll see you in the next video.